All right, welcome guys. In this video, we're going to be taking a look at the properties of two functions, and they really are the same function. They're just one of them is vertically stretched a little bit more than the other. So we're looking at f of x equals the log of x and g of x equals the natural log of x. So we want to learn more about the graphs of logarithms. So to start off, let's just look at f of x equals log of x. And the first thing I want to talk about is what is going to be the domain of this function. Well, let's think about logically, what values can we plug in for x here? So remember, if I have log base 10 of x, this question is asking me 10 to what power equals x? Well, I know for whatever power I have, whatever value I would plug in for that power, I can only get out a positive number. All right, so if I did 10 to any value, I'm only going to get out positive values for this x, meaning my domain for log of x is going to be 0 to infinity. It's only positive numbers. We don't include 0. If you were to go to your calculator and you type in what's log of 0, it's going to come back undefined. And the reason for that is, well, 10 to what power equals 0? Nothing, nada. 10 to no power is going to give you 0. It could get you infinitely close to 0, but it'll never actually touch 0. All right, how about the range now? So what values could I possibly get out? Well, let's think. If I did log of 10 to the negative 100, so 0.000000000, 100 zeros and a 1 at the end, or really 99 zeros and a 1 at the end. Well, what am I going to get out? I'm going to get out negative 100. So I can get out negative values. I could get values all the way down to negative infinity. And you can also get values all the way out to positive infinity. Imagine if you took log base 10 of 10 to the power of 5,000. Well, yeah, that's a huge x value, but it's going to give you 5,000 in the y value. So my range is actually all real numbers for the logarithmic function. All right, let's look at what the graph of this may look like. Well, we're going to have an x-intercept of 1, because we know that log of 1, well, 10 to what power equals 1 is 0. We are never going to cross the y-axis because our domain is 0 to infinity. So as we get closer and closer to 0, we're going to be going down to negative infinity. Then, as x gets larger and larger and larger, we're going to kind of flatten out. We know somewhere along here I have the point 10, 1. Further down the line, I actually have the point 100, 2. All right, so it's increasing. It's just increasing very, very slowly. We can say that there is a vertical asymptote here at the y-axis. So at x equals 0, we do have a vertical asymptote. So we've got our domain, we've got our range of log of x. For the natural log of x, everything is really going to be the exact same. All right, so if we go on to that next slide, natural log of x, well, our graph is still going to look the same. Like I said, it's just going to be a vertical compression, actually, of log of x. The reason for that being is, yeah, it still has the point 1, 0. I know the natural log of 1 is equal to 0. But now it's going to have the point e, 1. The natural log of e is equal to 1. And so this is just going to be a vertical shrink because on our last one, it had the point 10, 1. So it was taking a little bit longer to increase. So excuse me, this is a horizontal shrink, not a vertical shrink. All right, so again, we can still see that our domain of this function is still 0 to infinity. Our range is still negative infinity to infinity. We are increasing along its entire domain. So we're increasing along the domain 0 to infinity. What I want to do now is let's take a look at the similarities between f of x equals the natural log of x and then the function g of x equals e to the x. And in our next class, we are going to talk more about how these two functions are inverses. Okay, we've talked about that a little bit already, right? How do I get rid of the natural log? I need to do e to the power of both sides. So these functions are inverses of each other. And let's notice how their graphs relate, how their x and y values relate, so how their domain and range relate. So here's my graph of the natural log of x. Remember, we've got a couple of points here. We said we had the point 1, 0. We said we had the point e, 1. And we've got this vertical asymptote here at y equals 0. Or, excuse me, x equals 0, vertical asymptote. The y-axis is x equals 0. That's my fault. And for e to the x, well, we've got a horizontal asymptote as we go over to the left. We will cross through the y-axis at the point 0, 1 because e to the 0 equals 1. And then we'll also have the point 1, e. If we plug in 1, well, what's e to the first? It's just e. So then noticing looking at these two, we can see that they are inverses of each other. We had the point 1, 0 in the natural log of x. Here we have the point 0, 1. We had the point e, 1 in the natural log of x. Now we've got the point 1, e. We can also see that their domain and their range flip. Over here, my domain was 0 to infinity, so my possible x values were 0 to infinity. For e to the x, my possible y values were 0 to infinity. For e to the x, yeah, you could plug in anything you want into the exponent, so our domain was all real numbers, and for our range of the natural log function, our range was all real numbers. So we can see that these two functions are inverses of each other. All right, so we are going to do one more example problem. Let's just find the inverse. All right, we are going to find the inverse, and we are going to be given that f of x is equal to, let's do 3e to the x minus 5 plus 6. And we want to find the inverse. Let's remember how we do that. We start off by switching our x and y, and then we just need to solve for y. So I'll switch x and y. I get x equals 3 times e to the y minus 5 plus 6. I'll start off, I'll subtract 6 over to the other side. So I get x minus 6 equals 3 times e to the y minus 5. I'll divide by 3, so I get e to the y minus 5 equals x minus 6 over 3. All right, I need to take my work and bring it over here. Well, now I need to get rid of this e, so I'm going to take natural log of both sides. So the natural log of x minus 6 over 3 is equal to y minus 5, and I'll finish it out by adding the 5 over. So natural log of x minus 6 over 3 plus 5. Then I just need to write that as inverse f of x, and ba-boom, I am done. And we should be able to go in both directions with these problems. So best of luck.